All right, let's get right into it. The world is absolutely buzzing about AI, right? But what's actually powering this whole revolution? Well, it really boils down to two key things. This incredibly creative, deep tech engine that can generate new ideas, and then a super practical engineering blueprint that lets us turn those wild ideas into reliable tools we can actually use.
And you can feel the momentum, it's just undeniable. I love this quote. The genie is not getting back in the bottle. These AI agents are moving so fast from being some niche concept to something we're all going to be using pretty much every day. That shift isn't coming, it's already here.
But that brings up the real question, doesn't it? We've all seen those amazing AI demos that just blow your mind, but they only work that one time. So how do you get from a flashy prototype to a tool that you can actually trust day in and day out? That's the real challenge we're going to dig into.
And the answer really lies with this whole new wave of builders. See, it's not just about using AI anymore. It's about putting AI systems together in totally new ways.
This is where you start hearing all these buzzwords like agentic AI or multi-agent systems. And the core idea here is really powerful. Instead of having one giant AI try to solve a huge problem, you just break it down. You give smaller, specialized jobs to individual AI agents, and then they work together like a team or, a crew.
So what gives these agents their creative juice? Where's that spark come from? Okay, let's pop the hood and look at that first key ingredient, the generative engine. This is the really deep, complex tech that allows an AI to create something completely new.
At the very heart of this is something called a generative model. Its whole job is to study a massive amount of data. I'm talking thousands of pictures of faces, for example, and learn the underlying patterns so well that it can then generate a brand new, totally synthetic face that's never existed before, but looks completely real.
And this is where things get really, really efficient. An AI doesn't memorize every single pixel. No way. Instead, it finds the most compressed, elegant way to represent the information. For a circle, that's not millions of pixels, it's just two little variables, where the center is and what the radius is. That elegant, compressed idea, that's what we call the latent space.
So the AI's entire goal is to discover these hidden or latent variables for basically any concept. And let me tell you, this is a huge challenge in a field called representation learning, and it takes some seriously heavy-duty math to make it happen.
And here's just a little taste of what that math looks like. This is the KL divergence formula. Now, don't worry, we are not doing a pop quiz on this. The whole point is just to get a feel for the incredible theoretical complexity that's firing up this creative engine. It's deep, it's elegant, and yeah, it's a lot. But and this is the most important part. You do not need a PhD in advanced statistics to build with these things. And that brings us to our second key ingredient, the practical blueprint that makes all that crazy complexity totally accessible. I mean, just look at the contrast here. On one side, you have that mind-bending formula, and on the other, you have these simple, clear steps to start a project. This just perfectly shows the power of a good framework. It hides all the complexity, so you can just focus on building cool stuff.
Think about it like this. You don't have to understand the thermodynamics of an internal combustion engine just to drive a car, right? Well, it's the same idea here. You don't have to master the math of variational autoencoders to build powerful AI agents. These frameworks give you the steering wheel, the gas pedal, the dashboard, everything you need to just take control and go.
And the building blocks they give you are so intuitive. You just define your agents, say a researcher or a writer. You give them tasks like, go find me articles on this topic, and then you put them together in a crew to work together and get the job done. It's that simple, it's logical, and it is seriously powerful.
Okay, so this brings us right back to our big question. When you take that creative, kind of wild, unpredictable engine and you connect it to a structured blueprint, you immediately run into the biggest hurdle in AI today: reliability. Here it is. This is the core conflict. The very thing that makes the generative engine so amazing. Its creativity, its randomness, the fact that it doesn't give you the same answer every time, that is the exact opposite of what you need for a production tool. For that, you need reliable, repeatable results every single time.
And this is what we mean by the reliability gap. Look, an 80% success rate, that sounds pretty good for a prototype you're showing off to your team. But for a tool your customers are using, 80% is a complete disaster. You need to be hitting 99.9% or even higher. So how on earth do you close that massive gap?
Well, you close it with disciplined engineering.
This is where that blueprint becomes absolutely mission-critical. Frameworks give you the tools you need to tame that AI. Things like observability, so you can see what's going on, memory, so agents learn, guardrails to stop them from going off the rails, and of course, tons of testing to prove it all works. This is how you build trust right into the system.
So, let's bring this all home. The journey from a cool little prototype to a powerful production-ready AI tool is really about mastering the balance between these two very different forces.
It all starts with that incredible generative engine, right? That deep, complex, creative force that can dream up new ideas and solutions. That's the source of all the magic, the raw potential.
But all that potential is only unlocked when you channel it through a disciplined blueprint. It's the engineering framework that gives you the structure, the reliability, and the trust to turn that creative spark into a tool that actually works every single time and at scale.
And when you bring those two things together, the engine and the blueprint, you really unlock something new. It's a skill that lets you solve problems and build things that, honestly, were just not possible a few years ago.
So, that really just leaves us with one final thought. The technology is here, the blueprint is getting clearer by the day. The only question left is, what incredible things are you going to build with it?